Hello, my name is John Valdez, and I am a recent graduate of C&M's Deep Dive IoT Bootcamp. Thank you for joining me today as I show you my project that I've been working on for the last couple of weeks. So my inspiration for this project came from working at a concrete plant where it would get dusty within the warehouse at times. This was caused by clogs within the lines of the dust collecting system or filters becoming bad, worn out, or torn. So I wanted to make something that could measure the air quality as time progresses, whether it is exiting a smokestack that is attached to the dust collector system on top of silos or within a warehouse itself. As you can see here, this is a nice dust-free area. Clearly the bag house or dust collector is doing its job. In this next slide, as you can see here, this is what happens when filters become ripped or they become clogged, and excess dust, instead of being trapped within the bag house, they get released out into the environment, and this is what we are trying to avoid. Okay, so now for all the fun stuff. These next few slides are going to be all the parts that I use for this project. As you can see here, I am using the particle argon for the microcontroller. This has Wi-Fi capabilities, which allowed me to send data to a dashboard that I created online. And while doing so, this also let me send email and text alerts. And here is a Grove laser sensor. This is what I use to measure all the particles within the air. Here's an OLED screen. This is where I print all the data that is coming in from the laser sensor. And this is also where the user will navigate a menu to set the parameters for the sensor. And here we have two buttons. These are what the user will use to navigate the menu, and the rotary encoder will be used to change the values for the parameters. And then we have three LED lights just as a visual for the quality of the air. Green is when it's below the lowest value for the parameter. The red, as well as a buzzer, will turn on when it is past the highest threshold for the parameter, and then the yellow is everything in between. And here is the buzzer that is hooked up. That will go on once the highest value is been exceeded. A relay. This was required to give extra power for the buzzer. And here is the very first basic setup that I had. So this was my original setup that I had planned on using at the start of all of this. It is made out of some PVC pipe, a little bit of ductwork, and a small fan. And what I did was just toss some flour into the fan and it would blow through, and I had some coffee filters on the other end just before the dust sensor. So here I'm testing the LED lights just after I installed them to make sure that they're working properly. So for the rest of the testing in this video, I'm measuring the particulate matter that is 2.5 microns, which is the center value of the OLED screen there. So I have it set in this test to anything that reads 50 micrograms per cubic meter, the red light will turn on. Anything between 25 and 50, the yellow light will turn on, and anything below 20, the green light will turn on. And as you can see, it is also sending data to the dashboard that I created on ThinkSpeak. So these next slides is the testing for the buzzer after I had just installed it. I also want to give a warning if you are wearing headphones or if your volume is really loud to turn it down, because the buzzer does get fairly loud. And here is the menu to set your parameters for the sensor. Long press to enter and exit the menu. Just a single click for the black will scroll down, and red will scroll back up, and then just turn the encoder to set your value. Again, there's a low and a high. When it is below the low, the green light will turn on, and when it is above the high, then the red along with the buzzer will turn on. And here is a full example of everything working all at once. Alright, so that's going to wrap up my presentation for today, but before I leave, I would like to thank everybody at C&M Ingenuity, everybody in the Deep Dive Coding program, my instructors, Brian, McCool, and Tanda. Everybody has been such great help throughout this entire process, and everything has been smooth. I would like to thank my family, especially, for all the support that they have given me. And lastly, I would like to thank you for joining me today. I really appreciate it, and I'm glad that I was able to share this with you all. So with that, I wish you all a wonderful day. Thank you.